Okay, good afternoon everybody, and yeah, as Susan said, it's an Olympic panel. There's a hell of a lot of people here today. My name's Mike Hughes. I work for the Links in London, and I've kind of volunteered to try and keep this thing together. It's going to be a challenge. So what is it? People have said they wanted to hear about NAPs and get some more reports from the NAP/IXs that are in the world. In the right region, at the right meetings, we have a working group for this, specifically for this. There's over 20 exchanges in the right region. The working group takes 3 hours. Not all exchanges show up. And we run out of time. There's a lot more than 20 exchanges in the area where NANOG is. So we've only got a handful of people. We're tight on time, so it's going to be a time session. So we're going to run it in 2 halves. We're going to have a session now with 8 separate NAPs. Probably got about 10 minutes for questions at the end, provided everybody keeps their presentations nice and tight. And then we're going to have a buff later. We're going to have an open mic. Any other operators can step up, introduce themselves, say a few words about what they do. If they do want to bring presentations, they can. We're going to have a projector and all the rest of it. Kind of a whiteboard if anybody wants to draw stuff out. And have a discussion about things that might be affecting the NAPs at the moment, any issues people want to talk about. It gives you also a chance to meet the operators themselves in an environment that's probably smaller and a little bit more accessible than the general session as a whole. And then when we finish, probably go for some beer. So who's here? I'm going to introduce everybody, and if they can just wave in who they are as we go along. Got Lane Patterson from Equinix, Akio from Telehouse America, Paul Vixie from the PAX, Matthew Brooks from NAP of the Americas, Jeff Meltzer and Avi Friedman from Metro IX, Tom Beckley representing the Maze, Albert from Bell South, and Tony Hauser from SBC. Okay, so first up is Lane, so if you want to take the mic. And here's your presentation.
The clock's starting, Mike?
The clock is now running.
He's got a shepherd's crook over there. For 5 minutes he's going to yank me. Lane Patterson from Equinix. I have kind of an old-style NAP update in terms of an operations update of our switch fabric. And then I'm going to talk a little bit about what Jeb already presented. We're calling it Equinix, or the Internet Core Exchange, or ICE. And we opened Secaucus about a month ago, about 200,000 square feet, so our footprint is pretty much done now. In terms of switch fabrics, we currently have them in San Jose, Ashburn, and Dallas. Chicago's coming online in March, and it's a pretty straightforward exchange point using Foundries at the time, and unicast VLAN for public peering. We do private VLANs for virtual private peering. We let people run tagged on their ports. In terms of movement onto the switch fabrics, we don't require customers that have ASNs to be on the switch, and so it's kind of up to each individual customer's choice. We have 20 using it now. We have about 20 who have ordered it and are in the progress of setting up on the switch fabrics, and we have about 25 kind of in the pipeline. Gigi is definitely predominating as a choice over fast Ethernet. And we've done a little bit of work lately to get our website updated on a regular basis with critical information that you need to decide whether you want to do this. And so check out the following URL on the slide. Participants, this is the obligatory unreadable slide. So there are a lot of different types of customers in our centers, not just ISPs and carriers, but content enterprises, web hosting, wholesale companies like IBM and that kind of thing. Our architecture, again, pretty straightforward. We've got a big iron in the middle for Gigi and for trunking out to subtending zone switches. For copper distance issues on 10100, we had to do zone switches, which are currently swapping out net irons for big iron 4000s for that. And those are trunked back up into the core, and we've got hot spare of everything on site. There are some services you can reach. To tell you the truth, route servers aren't all that popular anymore. Route collectors, however, are extremely useful for getting BGP operational data, so we know what what the heck's going on, if traffic drops off or something like that, as well as for projects like Bill Woodcock, who are collecting research data by trending BGP announcements. So here's traffic. I chose San Jose. We seem to have had the most rapid rise in traffic at our San Jose location. And this is over the last 2 or 3 months, this has kind of grown. A couple of issues. One is, I think, Exchange Point put a lot of focus on their MOU for the stability of their fabric. And so layer 2, layer 3 devices have to be configured carefully. I think IXPs are starting to be swayed by ISPs in terms of jumbo requirements. We have an IPv6 VLAN set up now. Bill Woodcock is installing some BGP archive collectors in a lot of locations, among which is, I think, Ashburn and San Jose are coming up in the next month or so. So ICE, I think Jeb already did a pretty good job of describing this. How many more minutes, Mike? Oh, yeah, all right. It's basically a pretty simple bundle from Equinix's standpoint. It's a certain amount of rack space and patch panels, which are pre-provisioned optically to all the other people that buy this arrangement. So all you really have to do is do some pigtail fibers on the ends to bring up new connections between each other. It gives people a lot of flexibility on when they want to implement it, where, how. They can do their own technology into the building, a lot of different arrangements there. And surprisingly, there's about 15 companies in the process of moving in to do this architecture. The requirement is to do it in 3 locations, Western, 1 Central, and 1 Eastern. And for those of you, for lower speed peering, they do get a GigE port on the switch, kind of bundled in. So that's about it. Here's some contacts at Equinix you can take advantage of. I think, well, Jay and Bill and I are all here, and we have a peering alias. Feel free to send mail. For customers, they've been fairly successful at using our internal lists to kind of coordinate when they're coming in and what kind of people they're looking to peer with. Thank you.
Okay, great. Thanks, Lane. What we're going to do is take all the questions at the end, okay? So next up is Telegraph, so if you'd like to take the stand.
Okay. I'd like to give you an update from Telehealth Exchange Point. My presentation consists of 2 parts, current status and what's new. Current status, New York, our hardware is Cisco, carrier 5509, and the sorry. And we have found the big guy at 15,000. And the currently number of members is 1,007. And the peak is about somewhere between 400 to up to a little bit over 500. And we do have the what we call PHYSIX, which is a BGP-based ASPES visualization tool in Los Angeles. And architecture is like a metropolitan kind of exchange point. We interconnect with LAP, which is run by USC-ISI and Maine Los Angeles. Also, this hardware platform is carries 5509 again, and the total amount of members is 15, and our side is 3, and we're getting 4. And what's new? And before doing that, we pleased to announce that the just Telehouse and the Pikes have signed the kind of the agreement to interconnect all exchange points where we have both presence at any city in this U.S. country. So we'll start in New York and perhaps the West Coast very soon. And probably Paul is going to follow the information later. And what's new portion? MFP and MPLS. There is a project called GISTX, which is a kind of the government-funded project to research or assess MPLS-based exchange points. It was started since last year, And this project is actually formed in Japan, and Intel is a leader. And we have about over 20 organizations to do this. And this is a very interesting project because we have like a 1 week test period each time, probably every 3 months. And day one, nobody work, and something, nobody says yes. But day three, somebody starts getting yes, it works. And day five, like everybody started work. So very interesting situation. And we are honored to be a member of this project. And the key features of MPLS-based exchange point is data media independent, and also eliminate like side-party desktop or broadcast attack, whatever. And we like to incorporate this MPLS-based technology by fourth quarter this year. And we appreciate the cooperation and effort from all the members, project members. Also, I'd like to mention a little bit about new exchange point. Still no name, still under development. This is like a peering with payment, meaning paid peering. And the price is driven by the market. Setup puts the positive price they're willing to sell, or a buyer posts the price they're willing to buy. And of course, this is a usage-based billing. And we still developing the code, so every day we change the status, but we're trying to start beta test very soon, and if you would like to volunteer, you're quite welcome. And the version 1, which has very basic features, should start second quarter in New York. And the version 2, which has more full-fledged feature, like if you in a price, your bandwidth, time over the day, I want to sell bandwidth like a business time 9 to 5, a little bit higher price, or if your network is vacant, you can lower the cost, or even weekend or whatever. And the kind of full features version should be available in fourth quarter. Okay. That's the update from Federal Exchange Point. Thank you.
Okay, great, thanks. We're doing quite well here. Everybody's finishing in about 5 minutes. Next up is Paul. Paul's going to wing it, so there's no presentation material. Paul.
Hello, I'm Paul Vixie. I'm from PAX. Some of you know that PAX is part of MFN. So I guess I'm Paul Vixie from MFN, according to my paycheck, but my business card says PAX, honest. So the original PAX in Palo Alto is still quite successful. We've opened 5 other sites in Seattle, Dallas, Atlanta, New York, and Virginia. So most people know that, but I've run into a couple of people here who didn't know that we had any sites outside Palo Alto, so I thought I'd repeat the news. We are principally about peering, although there have always been a few content players. The fact is our centers are not large enough for the huge content plays. So when someone comes to us and asks for 20 racks and 100 amps per rack and so forth, we send them to one of our customers, perhaps AboveNet, who is also in the MFN collective. We have become one of the Metro Ethernet peering plays that you've heard about in the earlier presentations today. So you can now get PAX switch ports outside of PAX centers. One example would be in AboveNet centers. Another example, think about that, it's a place called Wave Exchange, San Francisco Wave Exchange, 200 Paul Street. It's a big fiber motel, and you can get PAX switch ports there in the San Francisco Bay Area. And you'll see us grow more switches. And the reason we decided to go into this is that MFN has all that fiber in those metros. The internal transfer cost is pretty low. So if you know what PAX's switch ports are. I can only say that they don't change just because we have, some metro connectivity to pay for, because I don't pay for it. If anything, the switch port cost outside of our centers will be lower. If it's different, it'll be lower, and the reason is I don't have to subsidize my colo with those particular ports. So that'll make us different from any Metro Ethernet play that isn't MFN or otherwise laden with Metro fiber. We recently announced that we are interconnected with the Seattle Internet Exchange. So those of you who were in the Weston building connected to the 6 can now reach PAX participants over a trunk, and of course vice versa. Interconnection of layer 2 clouds is very dangerous. Some of you know that PAX does not permit customers to attach switches to our switches, and that's just based on how painful it is when that particular configuration goes wrong. So in order to get connected to the Seattle Internet Exchange, we turned off most of layer 2. There's no spanning tree, there's no MAC learning, there's no nothing. So in order to get connectivity across that trunk, you have to sign a piece of paper that has your MAC address on it, and we put that into a static forwarding table. And we believe we're pretty safe from the kind of meltdowns that have plagued the layer 2 peering fabrics that do permit switches to be plugged into their switches. The other news is that Akio and I signed a memorandum of understanding to interconnect the NY-IIX and the PAX New York switching fabric. So we'll have that up for you just as soon as I can find the strand assignment man, because I know MFN has plenty of strands between 25 Broadway and 111 8th, so it's just a question of finding that person and getting them to allocate me a couple. So I'll be at the peering booth tonight to talk about these or sort of anything else folks want to discuss. I will add one comment. Someone asked the previous presenter, well, what is the difference between the next-gen peering initiative versus the NAPs? What is the actual fundamental technical difference? And to me, the difference is something that was PAX's original distinction. If you'll recall, when PAX was first brought to market, a lot of people asked me, gee, Paul, there are already 2 or 3 other NAPs in the Bay Area. Why do we need another? The answer is we were not a NAP. This was not a network play. This was a combined colo and network play. And so if you're on a switch, or whether it's an Ethernet switch in the same building with you, or an ATM switch that's over in San Ramon, whatever it is, when your trunk to that switch fills up, unless you are in the same building with the other people on that switch, you're probably just out of luck. So in a PAX or in these next-gen peering centers, the idea is you have the PNI. You've got dark fiber between you and the other people. So if either one of you fills up your connection to the switch, it's no big deal, because you've already paid to extend your network there. And so that, to me, is the distinction. In the traditional NAP, you had no PNI bypass that you could use when you filled your switch port. So that's my presentation.
Thanks, Paul. Okay, next up is Matthew Brooks from our host from NET of the Americas.
Termark owns and operates NAP of the Americas. It's based in the Technology Center of the Americas, or Dakota. It's a 750,000 square foot telecom hotel built from the ground up for that purpose. It's located about a mile to the northwest of here. The NAP is carrier neutral. It's based on Ethernet, foundry, big irons, also power our fabric. Based on our current architecture, we have a capacity of up to 128 gigabits per second. The NAP in Dakota and subsequently the NAP have a high and unique level of redundancy, generally based on the fact that the building is built to withstand a Class 5 hurricane. There are independent power feeds to independent substations, which have a capacity of about 80 megawatts, or 12 of those go to the NAP, which in domestic terms would power small city of about 12,000 people. We have a cooling source that has about 7,000 tons of capacity, and backup chillers on a roof that can deliver 2,000 of those, which again in household terms could power about 20,000 window air conditioning units. The building has 8 fiber ducts, which give the entire building a capacity of about 1.5 million fibers. A few weeks ago, when I put the presentation together, we had 59 signed customers. We've actually added a couple since then. Have a fairly international customer base, representing 5 continents. If you visit the naptheamericas.net website, you can get an up-to-date list, and we also break out carriers into the types of circuits they'll provide, as well as we give contact information for service providers. This is a list of customers who are pairing currently, or at least we believe they are. I think the list has been growing rapidly since the new year. A lot of customers are still being built out. The downturn in the economy in the end of the fiscal year delayed some of their build-out plans as well. But it's growing rapidly, and feel free to contact us if there's any information we can provide you to help facilitate establishing pairing agreements. We actually have 16 fiber routes in the building. 4 are not quite finished, and there's actually 10 undersea cable systems that are brought into the NAP through diverse paths. These systems have multiple origination points across Europe, the Caribbean, and South America. A few of the services that we have available today include traditional internet exchange, private and public VLANs. We can do data storage and management for full or incremental backups, archiving for long-term storage, or off-site storage for another layer of redundancy. We do network monitoring management, which allows us to basically operate a POP for you. We'll also do the design and build out of the structure, electrical, mechanical, and network systems for you, if need be. Traditional data center offerings, cages custom made to your requirements, cabinets, MPR with optical cable and copper cross connects, and Stratum 1 reference timing. Do professional services, remote hands, smart hands, or outsourcing. Sometime in the next few months, probably in the time frame of the NANOG 25, we'll add network security, monitoring, reporting, and actually management to our list. And we're also going to offer an optical cross connect platform. We'll do grooming from OC192, STM64 down to T1, E1, and we'll do SONET SDH conversion. Sometime later this year, these are some of the services we're researching: database and application monitoring and management, route control to influence route selection based on content. We will have an IP6 and multicast exchange, and we'll have ASP billing. This is my contact information. Everyone can feel free to see me during the show or get a hold of me after the show. The tour for tomorrow night is actually full, so we apologize we couldn't accommodate more. It's basically based on security reasons, the number we can accommodate. But if you're staying in the area for a little extra vacation, feel free to contact me, and I can be happy to set you up with a tour later in the week. Thank you.
Okay, great. Thanks, Matt. Next up, Jeff and RV representing Metro IX. You're going to do it? There you go.
So my name is Avi Friedman. I'm speaking on behalf of Metro IX, specifically with my NetAccess hat on. Metro IX is a joint project between Village World and NetAccess. So the idea is to target primarily Tier 2 providers and content providers, people who are in one carrier hotel type building in a metro area and to try to interconnect switches on a metro area basis to make it attractive for people to connect. The three first buildings that were brought up, and we have a building list, the two first buildings were 25 Broadway and 111 8th in New York, and there are other buildings also that we're interconnecting. Sorry. So you can run cross-connects inside the building, or you can be in a colo facility. Metro IX doesn't own or run or endorse any particular colo facility in any of the areas. In a metropolitan area, the network's built over dark fiber. The first generation was just using ZX-GBIX between switches. Now there's some coarse WDM gear, and given the eBay pricing, maybe we'll just proactively upgrade to dense WDM gear before we actually need to. We're not sure. But there's at least a gigabit of connectivity between each switch today, and at the current traffic levels of 10 megs per second or so, or less depending on the city, that's scalable for now. We don't anticipate any scalability issues due to the availability of 10 gig equipment. But today with the gear we have, we can go to 8 gigs, or at least 8 lambdas of GigE. We're using Cisco switches for actual attach. In terms of the long haul, there was some heated debate about whether or not to interconnect some of the metropolitan areas on the long haul, whether doing filtering or rate shaping or not, and the decision's been made not to do that for now, just to avoid a whole bunch of management issues. So instead, we've tried to make affordable long-haul connectivity available between at least a building in each metropolitan area. And as we look to expand to other cities based on the success of the first cities, finding affordable access on a long-haul basis for the Tier 2 type providers who connect, or content providers, is a key determining factor. In New York, we have the city list. We're live in 25 Broadway and 111 8th. 60 Hudson has really just been a demand question. In the Philadelphia area, there's a ring that goes 401 Pennsauken. The big question seems to be, and I didn't see Sprint, I don't think, on the list, finding people who will talk to you about, if you're already co-located in Pennsauken, about running interconnects. There was, a yes, we will do it, but then it tends to be hard to find anyone to actually run it. And 401 North Broad, their switch is actually in 2 or 3 of the rooms between MFN and switch and data and level 3, and that's just a cross-connect issue. In the DC area, live in 8100, but 1220L, again, looking for people who wanted to connect there before bringing that live. In the DC area, we actually are merging in connections to the ARS, the AVI RS exchange that we hooked up when MFS decided to stop selling May connections. We connected both Giga switches and May FIDI concentrators to allow people to at least connect because they had contractual need or they wanted to be able to move a little bit of traffic. And there are about 7 or 8 participants there who we're encouraging to move over to a supported infrastructure, although they're welcome to keep their Ethernet, FIDI, and switched infrastructure there as long as they'd like. And there are 3 locations inside 8100 Boone between the BovNet, the 5th floor May facility, and Suite 610, which is a net access facility. We have a number of people who are either hooked up or have committed that they're interested in hooking up, and again, we expect that as more buildings go live, the value proposition will be more compelling. So our plan is to look at other areas that we can expand to, ideally with some sort of long haul available to make it possible for people to parallel their backbones as they expand, and also to go to additional buildings based on demand. In some ways, it's actually become more difficult in some metro areas to get fiber. Some of the fiber companies want lots and lots and lots of money, or only sell on an IRU basis because they themselves have to make money instantly. But in some metro areas, there are a lot of, or at least there are some competitive dark fiber carriers who will sell, $2,000 a month for another, for at least a loop into a new building. So we have some contact information, and hopefully I came in under time.
Okay, great. Thanks, Elvi. Okay, next up, Tom from the main.
Hi, I'm contracted with WorldCom, do engineering for the May services. As we've looked to evolve the May service, most people are aware that it's an ATM-based platform, so one of the things we've looked at is efficiency of transport due to a large number of our customers are not colos with us. As you can see, the bottom entry is the least efficient. The other ones at the top, Ethernet and the frame, are more efficient. And so we've been working on evolving the platform to a frame interface over the past year or so, year and a half. Obviously, have efficient utilization of bandwidth. The border route, of course, for the customer are more economic to purchase, and they take up less router real estate. The service provisioning with the frame handoff is pretty straightforward. You're not exchanging routing, so you have a pretty similar handoff to ATM, a very clear demarcation. No routing information is exchanged, obviously, over that type of an interface. And again, that allows the technology to migrate as appropriate over time without changing the handoff to the customer. And again, then this supports a colo neutral architecture, which is a requirement of many of our customers. This year we launched the May FE service. Uses POS frame encapsulation as the handoff to the customer border router based on Juniper CCC technology. The service we're providing is best efforts. Which seems to be the preference for most of our customers at this point, where they're moving towards it. In this case, there is currently no policing or shaping. I think that comes in some later Juniper releases. ANSI, NXT, LMI, and the DLCI ranges are noted. The speeds offered are OC3, OC12, OC48, so we're moving up the food chain from that perspective. And again, in this exchange, if you're used to the May ATM services, the PeerMaker is a vehicle for customers to self-provision their connections without having to interact with WorldCom, at least explicitly. We have two sites. The one is open in Chicago, and we have one coming online in New York around the 1st of March. The other thing we're working on is interworking to increase the value proposition at the current May services platforms. And so this is the configuration we're testing in the lab. If you look at the box on the right, it could represent the current ATM platform, and then we'll put an interworking switch into the platform. We're testing this with multiple vendors in the lab today, and again, in the customer border routers could be connected either to the older or current, shall we say, ATM platform, or the new interworking switch. It could be frame, but it also could be other protocols on the interworking switch. And again, we're looking at deploying this service so that we can offer OC48 access for frame encapsulation will be OC3, OC12, OC48. Mid-year, the PeerMaker is being enhanced so that it will provision the interwork circuits. You won't start thinking about connections instead of PVCs, but it basically has the same functionality as the current platform has. And that pretty much covers what we're doing at this point in time. If you have any questions or need to contact info@may.net is pretty reliable. Thanks.
Okay, great. Thanks, Tom. Okay, next up is another local exchange. That's the Bell South Mix. And I'd like to invite Albert to take the stand. I sound like I'm calling people to testify, don't I? It's PDF. Okay.
Good afternoon. I'm going to move very fast, but I'll try to make sure I'm clear. I'll quickly start with just kind of some quick market dynamics, what's going on, and look at the benefits of what we've done in the Bell South Multimedia Internet Exchange in terms of building an optically mesh-based network. I'll give you a quick view of the architecture, talk about current service models that we're offering, and new service models that are under development and will be quickly deployed. I know the last 9 to 12 months has been very difficult for the telecom industry in general, but if we look back even 3 years ago from today, there's been tremendous pressure in terms of bandwidth. A T1 from New York to LA has decreased eroded in price some 40 to 60% over the last 3 years. So carriers and operators, those who are trying to provide bandwidth services, have to do something to overcome this consistent erosion. That really calls for the ability to build next generation networks that are more data optimized. If you look at the traditional metro area networks, whether they be for NAPs or just for services in general, they were built mainly on SONET ADMs, which created rings upon rings upon rings. It took a long time for customers to get services provisioned from point A to point B, as you had to provision over multiple ADMs. What we've done is really looked at the current generation of technology and built a optically switched metro network. So about a year ago, Bell South created a 272 compliant CLEC, Bell South Internet Exchange, and we have 4 locations here in the Southeast Florida area where we have again looked at the current constraints on network access points today, which were based on ATM, and they were single noded. And what we've built is a multi-noded infrastructure that's optically switched for more efficiency. Current services that we offer today range from DS3 to 192. We provide both public and private peering, ATM through optical. The basic concept is simple. Customers connect to any one of our 4 nodes via SONET or direct fiber and purchase ports off the infrastructure. And again, those ports range from DS3 to OC12 if it's ATM services, or DS3 to OC182 if it's optical services. New service models that we are in the process of deploying, one of those service models is Ethernet. When we looked at architecting the Ethernet service and gathered requirements and talked to customers, there's a great need for providing Ethernet services in very granular amounts of service in terms of 1 megabit increments. There's also a great need to provide transparent LAN capabilities for those who want to connect their local area networks across the Bell South mixed infrastructure. And in fact, the previous presentation from Earthlink is the exact model that we are deploying in our Ethernet service. So just a quick look at that. We've architected the Ethernet service in such a way where the core Ethernet switches are actually connected directly to the optical switch network. Another new service model is that of what we call customer network management. What we've done here is really extend our service management capabilities out to the customers. At a high level, customers can really manage and control the resources that are provisioned through the Bell South mixed infrastructure. On top of the current customer network management service model, we've extended that and are working with multiple carriers so that if you have multiple carriers that are connected to the mixed infrastructure, these carriers can actually share resources on each other's networks that are provisioned through our infrastructure. And in closing, there are tremendous benefits. I know I've gone fast, but there are tremendous benefits in what we've done. The current model, or if you will, the old NAPs or the old peering models, were that of ATM single noded. And what we've done is tapped into the latest available technology, which is optical switching. And we've built a fully redundant, multinodal network that provides not only that provides very cost-effective services and enables us to provision new service models and create them fairly quickly to meet market demands. Thank you.
Thanks very much.
And finally, last but no means least, from the SPC now, so training manager.
Thanks, Mike. Good afternoon, everyone. My name is Tony Heuser, and I'm the product manager for the SPC NAPS. First of all, I'd like to say thanks to NANOG, the organizers, for the opportunity to provide an update on the Ameritech and PacBell NAPS. Not only to discuss briefly where we are today, some of the attributes, but also then we'll want to talk about our next gen direction, which I know is the main focus here. Give me 1 second. Okay, so under the SBC umbrella, we have two NAPs, both of which were two of the original 4 NAPs awarded by the NSF. So the Ameritech and PacBell NAPs have been in operation for a while, since late '94. The Ameritech NAP is quite substantial. It's got about 130 customers, about 160 ports currently, and growing as we speak. And the PacBell NAP is at about 55 customers and 70 ports. A little bit different in architecture between the two. The Ameritech NAP, and let me say, by the way, you might know it as AADS. Ameritech had a data subsidiary for many years, long before the SPC acquisition. AADS stands for Ameritech Advanced Data Services, but I'm referring to the same entity. In any event, what is now ASI, Advanced Solutions, Inc., the later version of our data services company, it's in a data switch site in downtown Chicago, so it's centralized. And in PacBell, it's a distributed architecture where we have in the Bay Area 11 ATM switches co-located in PacBell COs, and we also have a smaller presence in the LA area, 2 switches. Both services, both NAPs, provide access speeds from DS3 to OC12C currently. We're certainly not installing much DS3 these days. Still doing a lot of OC3 and definitely a substantial amount of OC12. And certainly there is great impetus to move to a next generation, and clearly that's the more exciting area to focus on. But I do want to say, despite rumors of its demise, ATM and the Ameritech NAP are doing quite well. We had over 25% growth last year despite the economic conditions. So there's still a lot of demand, and clearly the size of the customer base is a factor. As far as busy hour throughput, Ameritech is at about 6.5 gig, PacBell at about 2.5 gigabits per second. A little bit difference in terms of the PVC deployment. In Ameritech, when a new customer signs on or is installed, we have an automated script that builds a full mesh of PVCs to every other customer. So then all the customer needs to do is form a bilateral peering agreement. We list the VPI, VCI information on our website, and they load that in the routers, enable it, and they're set to go. In PacBell, we have a more of a customized approach where we do it on an individual case basis or as needed basis, and provide some value-added benefit in tailorized support as that is done. Now, as far as where we're going, the Ameritech NAP particularly, we have a fairly significant research and education customer base. There are 2 entities. One is called MREN, Metropolitan Research and Education Network, and the other is StarTAP, Science Technology Advanced Research Transit Access Point. MREN is essentially the Big Ten university. StarTap is essentially the international equivalent. They're doing very computationally intensive advanced applications, and they use the Ameritech NAP as their exchange point. In any event, they are definitely leading edge organizations in terms of technology evolution, and they're currently working on a photonic switching trial with some production customers on it, actually, at Northwestern University. And we at SBC, various entities within SBC are working directly with them on that trial. And from my perspective, I'm working very closely with them in terms of our NAP development, so that in the near future we're positioned with the technologies they will need for these next generation applications and very bandwidth intensive requirements. So we're working really closely with groups that are very much on the leading edge of next generation development. So we're evolving to a packet switching environment. We clearly see the need for additional bandwidth, and we ultimately will be moving towards a light wave switching platform and hope to have point and click lambda provisioning. But again, we have a very extensive ATM base, so we have in phase 1 are definitely moving to deployment of our next gen platform. Phase 2 is to broaden that and really provide that gateway or mapping to our ATM legacy environment, potentially using GMPLS. And then finally, we're also looking at some advanced services. Again, this is being driven by our research and education customers. It will expand into our other customer bases, but layer 3 services, advanced multicast, IPv6, DiffServ, and some enhanced performance monitoring and reporting capabilities. And finally, contact information. Any general product questions I would be glad to address, and then I've also listed ASI North is the Ameritech region, and ASI West is our Pac-Bell region, and I've listed our technical operations and engineering folks. Thank you very much.
And so concludes the voting of the Miami jury. I'd like to thank all the participants for the fact that they're going to come up here and talk. I'd also like to thank them for the cooperation. We've had a very tight schedule to try and get all this in with 1 hour, so if we could show appreciation in the usual way. And questions. We have about 5 or 10 minutes. So has anybody got any questions? You can either direct them to the panel as a whole, or you could direct them to individuals. Susan.
Yeah, I had one come in for Paul. How does PAX handle customers connecting switches or routers such as the at 6509 to your switches?
For hybrid devices that can be configured on either a port by port basis or a whole config basis, to either be layer 2 or layer 3, we auto-config.
Hi, this is Jay Adelson with Equinix. I have a question for Tony. In September, we saw that a tariff was filed by SBC for the NAPs listed as ASI West and North. I was wondering if you can comment on that and what the benefit is to the customers, etc., and why that was done by SBC.
Jay, that is correct. The product is in our data subsidiary, and as SBC moves to become a less regulated company, there are a multitude of issues associated with the positioning of some of our services. And in our data company, it was essentially felt that the NAP, in addition to for the main reasons that we went to tariff for some of our products, ATM and Frame, the NAP should be included as it is a subset of our general ATM product currently. The reasons are much broader than the NAP or ATM specifically. SPC is moving to become a player in spaces that it cannot currently, and the impact of it really is hopefully nominal. We did not change any of our rate structures, and it is a dynamic environment, so going forward, it's unclear whether it would remain that way.
Just a follow-up question. One of the advantages to tariffs, I think, has to do with obviously price normalization, et cetera. Should customers of ASI North or West expect any changes to their current pricing or contracts as a result of the tariff?
No, any current contract is grandfathered, and there are no immediate plans for price changes other than obviously there's a downward pressure. So we have clearly the opportunity to file new tariffs, and that process has been set up. So in effect, it's really just a more of a bureaucratic process. It doesn't change our ability to market the product and be competitive on price. And then finally, let me just add that one of the driving factors and benefits that this will ultimately, this desire to accommodate the FCC is obviously our ability to have inter-LATA interstate services. And particularly most of our NAP customers are national, if not international. Right now, essentially we provide that port and local loop, and the customers meeting us through a third-party carrier. In the future, for those customers that would like an end-to-end service, nationally and potentially internationally, SPC can provide it. And obviously we'll have a lot of economy of scale and price flexibility in that respect. Hope I addressed the question.
Tony, don't sit down. One more for you. Why doesn't the PAC-Bell map automatically mesh the peering connections from customers? Has it been due to contractual requirements, resistance from the partners that are connected to the PAC-Bell map? What's the reason?
To be candid with you, one of my long-term charges as product manager is to create as much synergy between the NAPs as possible. And I won't take the time to go into a lot of the things we're doing, but one of the specific things that I was exploring was replicating what we do in Ameritech and PAC-Bell. So we would build a full mesh of PVCs. The net of it is that the current architecture, the current hardware platform, the BPX platform, has some limitations that would make that difficult. We plan to evolve it past that and address that issue. And really the issue is that in Ameritech, we do it through an automated script. So we can build 160 PVCs in about a half an hour. That was where the problem arose on the PAC-Bell side, is that the Cisco LAN manager had some limitations that wasn't going to allow that. But again, and clearly there are provisioning and interval issues, but we're making a concerted effort to minimize that interval. And again, at least the flip side or upside of it is that there's a personal contact who helps with that individual provisioning on an as-needed basis.
So the merger with Ameritech at least will give you some tools to leverage to replicate that code.
Absolutely. I mean, we've got a wealth of experience on the provisioning side, doing it in an automated fashion, and clearly this is all coming under one group. So for example, the chain of command is such that our NOC operations tier 2 support, it's one organization, and clearly there are internal efficiencies to be gained, but there's definitely advantages for our customer base too.
Yeah, thank you.
I guess along the same lines, I was curious if folks on the panel have had any traction with multilateral peering agreements.
Speaking for PACs, we don't have one. The reason being we want to give our participants the freedom to not peer if that's what they want to not do. Neutrality means freedom in both directions. Speaking for TICs, which I operated for some years, I can tell you that MPLAs don't work and don't do what you think they're going to do.
At the May services, we specifically don't have a multilateral clearing agreement, and we use the peer-making provisioning to allow customers to establish their own relationships at will.
Okay. Any more questions? No? Okay, great, thanks. Episode 2, tonight, 7:30, Chopin Room. It's on this floor, at the other end, at the opposite end from the registration desk. It's going to be an open floor session. It'll be a chance for any operators that are present here today that didn't get a chance to come up to the panel, to come up and say hi, say a few things about themselves. Hopefully we'll have an LCD projector. I've requested a whiteboard, so if we do want to go and go off and scribble things, we can. It's also a chance for you guys to actually go and meet the operators of the exchanges where you're participating now or may want to participate in the future and actually ask the questions. One of the things a lot of people have said to me, comparing the North American region to Europe, is people don't get in touch with the people that really run the NAP often enough, and that's going to hopefully give people a chance to do this. Hopefully some other presentations as well. I've already had one submitted, but really it's a bath, it's your session, so you come up with the ideas for it. 7:30 over there, and we'll go to the bar later. Thanks.